Hi, welcome to the session vSphere Data Protection. Backup, restoration, and disaster recovery are the most critical processes of data center management. Traditional data backup and data recovery solutions are expensive, slow, and complex. They write data to tape, which is difficult and time-consuming to restore. Traditional backup solutions were designed for physical environments, creating unnecessary complexity in virtual infrastructures. There are two basic methods of backing up virtual machines in a VMware vSphere environment. One way is running a backup agent of some sort in the guest operating system. And the second way, leveraging vSphere snapshots and vSphere storage API for data protection. Running backup agents inside the guest operating system can provide application and OS level integration. The backup agent can leverage the API of guest OS to integrate with OS and applications. For example, backup agents can leverage the volume shadow copy service in Microsoft Windows. This allows the backup agent to perform very granular backups, such as specific tables within a SQL database, particular mailboxes in Microsoft Exchange, or a subset of files within a Linux file system. The network traffic typically runs across the network, which can create network bottlenecks. This is especially true if the backup traffic runs across the same network as end-user facing traffic. To avoid bottlenecks with end-user facing traffic, organizations introduce dedicated backup networks. This means more network interface cards are required on ESXi hosts, as well separate virtual switches, separate physical switches, additional virtual NICs in the virtual machines, and additional complexity in the guest operating system. And the solution as a whole is going to be complex. Separate backup networks can also complicate troubleshooting and operations. The backup agents are individually running in each guest operating system, so as more and more virtual machines are consolidated onto physical servers, this creates additional overhead. Given that the overall utilization of the physical host was higher anyway because of consolidation, this leaves little headroom for the backup process, which in turn often translates to longer backup windows. Also, some backup vendors charge a separate license for every installation of the backup agent, which had a negative impact on the financial benefits of virtualization. Despite these drawbacks, there are advantages with this kind of approach. The tight OS and application level integration they offer make backup agents the preferred choice in areas where granularity and application integration are paramount. The second way that backups are accomplished in vSphere environments is to operate outside the guest operating system. vSphere data protection is specifically engineered for virtualization and administration capabilities of vSphere platform. VDP is a robust, simple to deploy, disk-based backup and recovery solution. VDP is fully integrated with vCenter Server and enables centralized and efficient management of backup jobs while storing backups in deduplicated destination locations. VDP is deployed as a pre-built Linux-based virtual machine. As many as 10 appliances can be deployed per vCenter server. Each appliance is deployed by default with 4 virtual CPUs and 4 GB of memory. 3 configurations of backup storage capacity are available. 0.5 TB, 1 TB, and 2 TB capacities are available. Careful planning is recommended to ensure proper sizing, as additional capacity cannot be added once the appliance is deployed. Storage capacity for deduplicated backup data is configured during deployment. The vSphere web client interface is used to select, schedule, configure, and manage backups and recoveries of virtual machines. Let us understand how VDP works. The backup software requests a snapshot of the virtual disk for the VM to be backed up. vSphere creates a snapshot, and all writes to the virtual disks for that VM now start flowing into the Delta disk. The base VMDK files are now logged. The backup application unlocks the base VMDK file and backs up the files to a backup device. When the backup of the base VMDK file is complete, the backup software requests vSphere to commit the snapshot. The writes in the Delta disk are committed to the base VMDK and the snapshot is removed. The process repeats itself for the next virtual machine. With this method, there is generally less processor and memory overhead because there is no need to run a backup agent inside every guest operating system. Depending on the environment, this might afford you the ability to achieve higher consolidation ratio or provide better performance for your workloads. VDP reduces both the load on virtual machines and hosts as well as network bandwidth. Through tight storage API for data protection integration, VDP leverages change block tracking, sending only unique changes over the network in order to minimize traffic. The process is completely transparent and automated, enabling up to 8 virtual machines to be backed up concurrently. Since VDP resides in a dedicated virtual appliance, backup processes are offloaded from production virtual machines. However, there are some disadvantages with VDP. Because there is generally a little or no coordination with applications running in the guest operating system, VDP-based backups typically cannot provide same level of backup or restore granularity as in guest-based backups. There may also be issues ensuring application consistency. VDP uses change block tracking to perform incremental backups on virtual machines during image-level backups. CBT also comes into play during virtual machine image-level restores to improve speed and efficiency. CBT identifies and tracks block changes since the last backup and stores these changes in the log file. VDP queries vSphere for any block changes through VADP and gets the list of blocks that have changed since the last run of this particular job. During the restore process, VDP leverages the vSphere API for data protection to determine which blocks have changed since the last selected restore point. VDP automatically evaluates the workload between both restore methods, restoring all blocks or calculating and restoring only the changed blocks, and uses the most efficient method. VDP utilizes built-in data deduplication technology to eliminate duplicate storage blocks as backup data is written to the disk. This helps to minimize disk space consumption. Therefore, vSphere administrators can maintain multiple point-in-time copies of virtual machines using only a fraction of the storage that would normally be required versus storing multiple full copies of a virtual machine. Deduplication segments an incoming data stream, uniquely identifies data segments, and then compares the segments to previously stored data. If the segment is unique, it is stored on the disk. However, if an incoming data segment is a duplicate of what has already been stored, a reference is created to it, and the segment is not stored again. For example, a file or volume that's backed up every week creates a significant amount of duplicate data. Deduplication algorithms analyze the data and store only the compressed, unique segments of a file. This process can provide an average of 10 to 30 times reduction in storage capacity requirements, with average backup retention policies on normal enterprise data. This means that companies can store 10 terabytes to 30 terabytes of backup data on a 1 terabyte of physical disk capacity, which has huge economic benefits. VDP uses variable length deduplication. Let us see how variable length deduplication works. Client software examines the file system and applies a secure hash algorithm to variable length data segments. Each data segment is assigned a unique identifier. The client software then determines whether this unique ID has already been stored. If this object already exists, a link to the stored object is referenced in the backup. In this way, the same segment is never backed up twice. By providing the highest possible level of deduplication, variable length deduplication reduces backup storage, it improves backup times, and lowers the cost. The advantage of using VDP is that no backup agent installation is required. use of virtual machine snapshot functions is enabled. Backup processing is offloaded from ESXi host to a backup server. Thus, ESXi host resources are not used for backup processing. Virtual machines see the same virtual hardware, so they can be restored to any x86 hardware. Virtual disk can be thin provisioned and saves the space. Faster backup and recovery times are enabled through the use of change block tracking and data deduplication. A single backup image can be created. Both image level and file level restoration can be performed. vSphere data protection is based on the industry-leading EMC Avamar backup and recovery solution and is available in 2 editions. vSphere data protection included with vSphere Essentials Plus and vSphere Data Protection Advanced is purchased separately. Basic VDP functionality does not require a license key. For VDP Advanced users, after the host is licensed and the system is in VDP Advanced mode, the extended features become available. Once licensed, users are restricted from creating backup jobs containing virtual machines on unlicensed hosts. VDP supports up to 2 terabytes of deduplicated backup data capacity. Assuming average virtual machine sizes, average data change rates, and a 30-day retention policy, approximately 50 virtual machines can be protected with a 2 terabyte appliance. VDP Advanced scales to 8 terabytes of deduplicated backup data capacity. It can protect up to 200 virtual machines on an average. Prior to deploying vSphere data protection, users should plan adequately to help ensure proper sizing because extra storage capacity cannot be added after the appliance has been deployed. In contrast, VDP Advanced enables dynamic provisioning of additional capacity up to 8 terabytes of total. VDP is deployed using vSphere Web Client from a prepackaged Open Virtualization Archive file. The same OVA file is used for both basic VDP and VDP Advanced deployments. VDP Advanced functionality is enabled by entering a license key. This can be done during or after deployment. After the appliance has been deployed and powered on, a browser is used to access the VDP configuration user interface and perform the initial configuration. The first time a user connects to the configuration user interface, it will be running in install mode. With the install mode wizard, items such as IP address, hostname, DNS, time zone, vCenter server connection information, and storage configuration are entered. A performance storage test can also be run at this time, which is highly recommended to validate that the storage on which VDP is running meets or exceeds recommended performance levels. Upon successful completion of these tasks, the appliance must be rebooted, which will take several minutes as the appliance automatically finalizes its initial configuration. After initial configuration, the VDP configuration UI runs in maintenance mode. In this mode, the functions such as starting and stopping services in the appliance, collecting logs, and rolling back the appliance to a previous valid configuration state are performed. After the installation is done, install the VDP plugin in your vSphere web client and then connect to the appliance. Creating and editing a backup job is accomplished using the Backup tab of the VDP UI in the vSphere web client. Individual virtual machines can be selected for backup. Users also can select specific virtual machine disks for backup. For example, an administrator might want to put the operating system, applications, and data on a separate VMDK file. If the requirement is only to protect the data, the administrator can select only the virtual machine disk containing the data, which helps minimize backup capacity consumption. Containers of virtual machines such as data centers, clusters, and resource pools can also be selected for backup. When a virtual machine is added to the protected container, it automatically is backed up. Likewise, when a virtual machine is removed from the container, it no longer is included in the backup job. previous restore points are preserved until expired by the retention policy. Backup jobs can be scheduled daily, weekly, or monthly. Each job starts at its scheduled time and runs once in the day it is scheduled. The retention policy can be defined in a few ways. For example, retention for 60 days or until a specific date. A custom retention policy also can be defined. After a backup job has been created, it can be edited or deleted. It is also possible to clone a backup job. Cloning can be useful if, for example, the backup administrator wants to easily duplicate an existing custom retention policy for a new set of virtual machines. The administrator can clone the existing backup job and edit the selected virtual machines in the new backup job. The initial backup of a virtual machine can take some time because all data blocks that make up that virtual machine must be backed up. Subsequent backups typically take much less time because VDP uses change block tracking in vSphere. Restoring an entire virtual machine is performed using the Restore tab in the VDP user interface. The administrator can browse the list of protected virtual machines and select one or more restore points. Individual virtual machine disks can also be selected for restore. VDP offers fast and efficient recovery by leveraging change block tracking. When restoring an entire virtual machine to its original location, the workloads of both a full image restore and a restore leveraging CBT are evaluated. VDP intelligently determines which method will result in the faster virtual machine recovery time. To prevent overwriting an existing virtual machine, a new virtual machine name and destination data store can be specified. Choosing a restore location other than the original will result in a full image restore. There are also options to power on virtual machine and reconnect its network adapter after the restore has been completed. With VDP, it is also possible to restore individual files, folders, and directories within a virtual machine. File-level restore is performed using a web-based tool called VDP Restore Client. The process enables the end users to conduct restores on their own without the assistance of an administrator by selecting a restore point and browsing the file system as it looked at the time that backup was done. They can locate the item to be recovered, select a destination for the restored items, and start the recovery. The process of the restore job can be monitored in the VDP Restore Client. The Reports tab in vSphere Data Protection and VDP Advanced displays a variety of information such as appliance status, used capacity, backup job and virtual machine backup details, and so on. There are links to the Event Console and Task Console for additional information and for troubleshooting purposes. The list of virtual machines can be filtered using several criteria. For example, virtual machine name or date of the most recent backup. The Details section displays specifics such as virtual machine name, guest OS, backup status, and date of last successful backup about the virtual machine selected from the list of clients. In addition to user interface reporting capabilities, VDP can be configured to send email reports scheduled at a specific time, once per day or all days of the week. Similar to the UI, these email messages contain details on the VDP appliance, backup jobs, and the virtual machines that are backed up. VDP and VDP Advanced contain a checkpoint and rollback mechanism. A checkpoint is a system-wide backup of VDP appliance that is performed to help protect the appliance from risks that might cause data corruption, such as an unexpected appliance power-off. In this case, the appliance would roll back to the last validated checkpoint. Any backup jobs performed after that checkpoint would be lost, but data corruption, that is, loss of all backup information, likely would be avoided. VDP Advanced application agents are downloaded using vSphere web client and are installed in the guest operating system. If the virtual machine is running Exchange Server, SQL Server, and SharePoint. VDP Advanced adds the ability to properly backup and restore Exchange Server, SQL Server, and SharePoint. Application agents are installed in the guest OS of the virtual machines running these applications. VDP Advanced leverages these agents to backup and restore the application databases. Using an application agent enables application consistent backups and provides support for other options such as full, differential, or incremental backups, enabling multi-stream backup and database log management. VDP Advanced can replicate backup data to another VDP Advanced appliance and EMC VMware. This capability is especially useful to move backup data offsite in a secure and reliable manner. VDP Advanced can replicate and backup data to another VDP Advanced appliance and EMC VMware. This capability is especially useful to move backup data offsite in a secure and reliable manner. Because the backup data already is deduplicated at both the source and target, only unique data segments are replicated. The replicated data is encrypted and compressed to secure it and to further minimize network bandwidth consumption. When creating a replication job, it is possible to define specific criteria for which backup data is replicated. Individual clients, virtual machines, and applications can be selected for replication. Specific backup types, weekly backups, for example, can be chosen, and date restrictions can be defined. The replication job can be scheduled to run daily, weekly, or monthly. By default, the retention policy of the replicated backup data is the same as what was defined in the backup job for that backup data. A different retention policy for replicated backup data can be defined. For example, an administrator might want to retain backup data locally for 30 days and retain the same replicated backup data offsite for 180 days. Performing restores from replicated backup data is very similar to performing restores from local backup data. VDP Advanced provides the ability to restore individual SQL Server and SharePoint application databases. Because VDP Advanced leverages specific application agents, various restore options can be defined for each application. This screenshot shows options available with SQL Server agent. The VDP Advanced agent for Exchange Server enables individual database backup and restore. It is also possible to select individual mailboxes for restore. Backup verification jobs can be created in VDP Advanced. These jobs automate the process of restoring a virtual machine, powering it on, verifying the guest OS is booted by detection of VMware tools heartbeats, and optionally confirming an application started successfully by means of a custom script. The restored virtual machine is disconnected from the network to prevent interference with production systems. After the restore and verification has been completed, the restored virtual machine is deleted to free up the capacity. Backup verification jobs can be scheduled at specific times, daily, weekly, or monthly. VDP Advanced can be configured to use data domain as a backup data target. The advantages of doing this include additional scale, global deduplication, and improved backup efficiency due to the data domain boost libraries built into VDP Advanced. Backup data replication can be configured between two or more VDP Advanced appliances with separate data domain targets. Replication is configured and backup metadata is maintained in VDP Advanced, but replication of backup data occurs directly between data domain appliances. Data at the source and target is already deduplicated. Only unique data segments must be replicated, minimizing the amount of network utilization. Replicated data is encrypted and compressed for additional security and efficiency. There are numerous replication topology options with VDP Advanced. Replication can be done one-to-many or many-to-one configurations. Backup data replication can be configured between 2 or more VDP Advanced appliances with separate data domain targets. Replication is configured and backup metadata is maintained in VDP Advanced, but replication of the backup data occurs directly between data domain appliances. Data at the source and target is already deduplicated. Only unique data segments must be replicated, minimizing the amount of network utilization. Replicated data is encrypted and compressed for additional security and efficiency. There are numerous replication topology options with VDP Advanced. Replication can be one-to-one or one-to-many and many-to-one configurations. The table here summarizes the features supported by basic VDP and VDP Advanced versions. This concludes our session about vSphere data protection. We have covered about the backup methods available for vSphere environment. Then we covered about VDP Appliance, its deployment options, and the features of basic VDP and VDP Advanced. Thank you for watching.